All right, so I'm going to use the problem from the most recent quiz you guys took to talk about calculating the frequency. So I see kind of this portion here. Actually, let me use a highlighter. I'll highlight what I see as one cycle. I see a pattern where we have this lumpy part above, then it comes below, and then it stops. So that's kind of what I see as one cycle. You could have counted all of them or not. Let's say that I counted all the ones I didn't highlight. Let's say I counted from here over to here, and that's where I say it ends. Then I would have counted 1, 2, 3, 4, 5 cycles. So this would contain 5 cycles. So you didn't have to necessarily have 5. I looked at where you guys marked. And then the number of seconds, we need a start time and an end time. So what we want to do is we want to look at the times that we think these are. So my start time looks like 1.633. And then I got to look at the scale. So this is like 30, this is like 40. So this one in between would be like 35. So I think that's like 30. That's probably like 31. And then my end time, I marked at the very end of the picture, which is here. I can't quite see the mark yet for the 5. Like the next number should be 395. Any little mark, but there's not a little mark there. So I'm going to call it 1.6394. Okay. And so you guys could have left start time and end time and gave you credit if I could see those there. And then some of you did actually put the number of seconds. The number of seconds is just what we get when we subtract these two things. So when I do 1.6394, that's the end time, minus the start time, 1.6331, I get 0.0063 seconds. And if I take 5 and divide it by 0.0063 seconds, I get 793.7. And then you guys had a reference to look up which note that was and in which octave. And so this would be calculating frequency. And then if you guys want to write equations of that, okay, I'll work on each of those here too. So this one, we're going to write a sine equation. What we need to remember about a sine function is, in general, its parent goes like this, meaning we're viewing the starting position of the wave as being on the midline and then kind of heading upward for the wave. So I want to choose the start of my sine wave somewhere where I see that happening. So I could choose my start time right here because I feel like that's kind of like the beginning of a sine wave, that it's on the axis and it's headed up, even though I understand that that's going to kind of generalize like this and not look exactly like what's happening there. So here, when I look at the equation, the A value, A is amplitude, okay, and that's going to be compared to what the scale is here. This says 0.1, and it looks like it makes it about halfway to that. So I'm going to call my amplitude 0.05. Now in your project, because we had to switch to the app because of the software issues at our school or the technology issues, you don't have necessarily that scale. So you guys can literally make up an A value on your screenshots. So the next things I want to fill in are my B, my H, and my K. So we talked about K always being 0 because all of our recordings are centered on this midline and they don't actually go to another position. And then the H value is where we want to say we've shifted the starting point to. So technically it could be infinitely many values because all these places I'm starring in green right here, I feel like could be used as initial starting points for a sine graph function. So you just need to pick one of them. I'm going to pick this one here because I already picked out what time that was as my start time. And I'm going to use then that as my H value because I feel like this is the start of a sine wave. It lines up with the x-axis right here, which is this 1.6331 value. So that's what I would use as my H value, my horizontal shift, that I'm starting a sine function at that value. And then lastly is my B value. So I want you guys to remember for both sine and cosine, we said that the parent function period was 2 pi, that all those functions started with a period of 2 pi. That the only way we could change the period was through horizontal compression or stretching. So when that happens, we take the b value from our equation and we use its reciprocal. And then that's supposed to give us the new period of our function. Okay. So right now you guys may argue that you don't have a new period, okay? But you need to remember that frequency and period have a relationship, that they are reciprocals of each other. So given that you guys have calculated a frequency for each of the screenshots you have, if I know the frequency is 793.7, then I actually do know the period. The period is going to be the reciprocal of that number. Okay. So my new period that my graph is supposed to make is 1 over 793.7. So if I finish solving this equation for b, I would have 2 pi over b equals 1 over 793.7. Then if I cross multiply, b times 1 gives me b. 2 times 793.7 gives me 14, 6, 7, 18, 1,587.4 pi. So that's my b value. And then I'm going to put it all together in an equation. So the format of our equation looks generally like this. So for my sine equation, I have my a value. It's a sine function. I have my b value. And I have my x minus h value. I'm going to erase my graph to make it fit here. Sorry. And so that would be a sine function. We should all have basically the same values. Like I could be able to easily check from your frequency in the picture, your amplitude and your b value. And then I would check that your h value met the requirement. Because sine and cosine are so similar, almost everything is going to be the same. So the same amplitude, the same period and frequency, so the same b value. There's no vertical shift, so the same k value. So with cosine, the only thing that's going to change is the h value. And that's because a cosine equation normally starts like this for the parent function. So we're trying to identify a maximum value as the starting position. So let's say I identify something like this as my starting position. Again, there could be a lot of them. If I identify that as my starting position because I see it as a maximum in the function, and I look at where that goes to this value right here, 1.635. So in this case, my h value would be 1.635. So that's really the only thing that's going to be different if I decide to write a cosine equation in my project rather than a sine function, is that I will have a different h value. And you guys are supposed to do 2 of your notes with sine functions and 2 with cosine functions. So hopefully that helps remind you guys how to write equations or find frequency, and you guys can ask whatever questions you need.